Hailed as the #1 delicacy of the sea for over 1,000 years, abalone has captivated the world not only with its refined flavor and exceptional nutritional value compared to other seafood, but also with the painstaking journey of cultivation hidden beneath its iridescent shell. So how is it that every year, more than 200,000 tons of abalone are farmed, harvested, and processed to supply the global market? The journey of this soft gold of the ocean begins at coastal farms, where tiny life forms are nurtured in strictly controlled environments, before being transferred to large tanks or suspended baskets in the sea to continue growing. Once they reach their ideal size, abalones are harvested by skilled hands, then sent to modern factories to be processed into premium frozen or canned products, ready to grace the tables of the world's elite. Today, join Agriculture Insight as we uncover the fascinating process behind this legendary marine treasure and reveal the secrets that make abalone worthy of the title King of Mollusks. All will be unveiled in this video. China is now regarded as the world's abalone factory, accounting for up to 85% of global production thanks to large-scale industrialized farming with competitive costs. In contrast, South Korea stands out with its focus on quality and building a strong national brand, creating a stable and highly valued market. On the other side of the globe, Australia does not chase volume, but instead positions abalone as a symbol of luxury, producing only 1/200 of China's output, yet commanding prices 5 to 10 times higher thanks to its intensely sweet flavor, firm texture, and absolute safety. Together with sea cucumber, shark fin, and lobster, abalone is ranked among the 4 great treasures of the sea, a symbol of rarity and opulence. Beyond its richness in protein, minerals, omega-3, and essential amino acids, abalone has conquered gourmet palates with its delicate sweetness, lingering umami, and uniquely tender crisp texture unlike any other seafood. Moreover, its long farming cycle of 18 months to 3 years significantly drives up production costs. Each year, the legal abalone farming and processing industry generates more than $2 billion globally, with the highest end segment reaching premium prices of $500 to $1,000 per kilogram. Now, join us as we explore the abalone farms, the very birthplace of this extraordinary journey of what is known as the soft gold of the ocean. The journey to building a $1 million abalone farm begins with one essential and highly critical step: selecting the broodstock for the spawning season. To produce generations of healthy abalones with fast growth and high survival rates, broodstock must be carefully chosen, each weighing between 120 and 200 grams, aged 2 to 3 years, with bright shells free of deformities, and showing quick responses to stimulation. Once the ideal candidates are selected, they are separated into specialized spawning tanks to undergo artificial fertilization. Abalones reproduce through external fertilization. Both eggs and sperm are released into the water through the genital pore in liquid form. On farms, breeders first collect sperm from tanks containing the males, then introduce it into incubation tanks where hundreds of thousands of eggs from the females are waiting. The water temperature is kept stable at 20 to 22 degrees Celsius with gentle aeration and almost no current, since even a small deviation could ruin the entire batch. After about 10 to 15 minutes, the eggs are successfully fertilized and begin the process of cell division. About 18 to 24 hours after fertilization, abalone eggs hatch into trochophore larvae, spherical in shape, moving with cilia, and sustained by yolk reserves. Over the next 3 to 5 days, the larvae develop into the veliger stage, beginning to form a thin shell and a creeping foot while still swimming freely in the water. At the late veliger stage, when they are ready to settle, The larvae are transferred into tanks equipped with special substrates, such as PVC plates or rough tiles, coated with benthic microalgae, serving both as an attachment surface and as their first food source. Over the next 2 to 3 months, they gradually lose the ability to swim freely, undergo morphological changes, develop a harder calcium shell, and begin to resemble miniature abalones. At this point, firmly attached to the substrate, they are called juvenile abalones and officially enter the grow-out phase. From here, abalone farming moves into a more specialized stage with various models and methods depending on climate, geography, and infrastructure. However, in general, it can be divided into 2 main systems: land-based farming and sea cage culture. In countries such as Europe, Australia, the United States, and South Africa, where offshore conditions are often unstable, land-based farming has become the preferred method. Abalones are raised in closed recirculating tanks, with some farms adopting multi-tiered, semicircular tanks designed in a stepped layout to save space, simplify cleaning, and facilitate harvesting. The tanks are usually lined with composite materials or built from concrete and stocked with seaweeds such as red algae or kelp as a natural food source. Water temperature is maintained at around 18 to 22 degrees Celsius with continuous aeration systems to provide oxygen and simulate gentle water flow. In this method, abalones are fed directly with fresh seaweed or with seaweed harvested and preserved in advance, then distributed into each tank according to feeding rations. Some facilities also use ground-dried algae or algae pellets, making it easier to control quality and extend storage time. Meanwhile, in Asian countries such as China, South Korea, and Japan, where coastlines are long, seas are sheltered, salinity remains stable year-round, and the climate is temperate, sea cage farming is far more common and widely applied. In this method, juvenile abalones age 2 to 3 months, once they reach a size of 1.5 to 2 centimeters, are transferred into suspended baskets or multi-tiered cages in the ocean. Each cage contains multiple compartments, anchored beneath floating rafts in areas with gentle currents and clean seawater. Feeding is carried out once a day, often supported by mechanical equipment. Kelp, the main food source for abalone, is harvested and bundled into large bunches, placed on steel racks or haying trays, then lowered into each cage using cranes or mini hoists. This method reduces labor, distributes seaweed more evenly, and ensures abalones in all cage levels have access to food. Compared to land-based systems, sea cage farming excels in scale and output by making use of vast areas, lower costs, and nutrient-rich natural seawater. One reason why China and South Korea remain world leaders. However, in terms of quality, land-based abalones from Australia and the United States can fetch 1.5 to 2 times higher prices thanks to their uniformity, reduced microbial risk, and strict environmental control. Compared to seafood like oysters, scallops, or green mussels, which can be harvested in just a few months, abalone requires at least 18 months to 3 years from its larval stage. Only when they reach a length of 6 to 12 centimeters, with a uniformly hardened shell, thick flesh, and stable weight, are they considered ready for harvest, marking the culmination of a long and meticulous farming journey. A harvesting process begins by lifting individual abalone trays from the sea, using cranes or automatic winches. Each tray usually holds around 200 to 300 abalones clinging tightly, weighing several dozen kilograms, so mechanical support is required to ensure safety and to prevent the abalones from falling off. Immediately after, workers carefully detach the abalones from the trays or rearing racks using specialized tools, taking care not to damage the foot, the most valuable part of the meat. Due to their extremely strong grip, many must be pried off with thin, specialized blades, and workers must handle them with precision to avoid tearing the flesh, which would reduce their market value. Next, the abalones undergo preliminary cleaning of their outer shells to remove algae, silt, and small parasites attached to the surface. They are usually rinsed with clean seawater or a mild disinfectant solution to minimize bacteria and help preserve freshness before the sorting stage. Here, the abalones are placed onto automated conveyor systems where each individual is separated according to size and weight. This meticulous grading not only accommodates diverse packaging needs, but also meets the strict standards of different markets. For example, Japan favors perfectly uniform abalones, while China prefers larger sizes to serve in high-end restaurants. Finally, after sorting, the abalones are packed into foam boxes with oxygen supply or kept chilled, then transported to processing plants or distribution centers, ready for the next stage of their journey to dining tables around the world, particularly to high-end restaurants where absolute freshness is required. As soon as they arrive at the processing plant, the crates of live abalones are moved by forklifts directly into large cold water tanks, equipped with continuous aeration systems to maintain dissolved oxygen levels and reduce stress. This stage allows the abalones to recover after long transport and ensures the meat retains optimal freshness before processing. After this recovery soak, the crates are transferred to the processing line, where workers use specialized tools to carefully detach each abalone from the plastic trays or rearing racks. The next step is cleaning, a highly critical stage. Abalones are first scrubbed manually with soft brushes to remove algae, sand, and debris from the shell surface. They are then placed into rotary drum washing machines equipped with high-pressure water jets for a final thorough rinse. This process not only ensures food safety and hygiene, but also enhances the appearance of the abalones before further processing. Once the abalones are thoroughly cleaned, workers proceed to separate the meat from the shell using specialized knives. At the same time, they remove the viscera, digestive glands, and the dark-colored gut, parts that are not edible. This step requires great skill and experience to avoid tearing the flesh or damaging the soft fringe around the body, which is rich in nutrients. After being separated, the abalone meat is neatly arranged into stainless steel trays and placed into blast freezers at temperatures ranging from -40 degrees Celsius to -60 degrees Celsius. This rapid freezing method preserves the natural texture of the meat and prevents microbial growth. It is the most common preservation technique, extending storage life without the need for chemical additives. After freezing, abalones can be packaged either whole or sliced, depending on market demand. The packaging used is typically vacuum-sealed bags or molded plastic trays, ensuring that flavor, moisture, and food safety are preserved throughout transportation and distribution. For premium canned abalone products, the pristine white meat, after thorough cleaning, is carefully inspected by hand and eye to ensure it is free from defects. Each piece is then weighed with precision down to the gram to guarantee uniformity across every can, a crucial requirement in high-end markets such as Japan, the United States, and Singapore. Finally, the finished cans are labeled with detailed information on origin, production date, and expiration date before being boxed and shipped worldwide. Imagine yourself diving into the deep ocean, where fine sand and briny waters conceal ancient creatures that have existed for over 400 million years. Welcome to China, the global capital of sea cucumbers. Every year, this country produces and harvests more than 200,000 tons of sea cucumbers, accounting for over 2/3 of the world's supply and leaving all other competitors far behind in the international market. Sea cucumbers are often nicknamed sea dung because of their rough, bumpy appearance and their typical brown or black colors, which easily cause misunderstandings. In truth, however, they are better known as sea cucumbers, thanks to their elongated, plump bodies covered in prominent bumps that strikingly resemble fresh cucumbers on land. And have you ever wondered how such peculiar creatures actually breathe? Yes, you heard that right. Sea cucumbers breathe through their bottoms. Through tiny openings at the rear, they draw in oxygen-rich water and then expel it, sustaining their lives on the ocean floor. This extraordinary breathing method is the very secret that allows sea cucumbers to survive so remarkably in the vast ocean. This unique way of breathing not only helps sea cucumbers sustain life, but also facilitates their extraordinary mode of reproduction in the ocean's depths. In the wild, the male arches its body and gently releases sperm into the water, while the female releases eggs, allowing the two to merge and undergo external fertilization. The fertilized eggs then develop into free-swimming larvae, passing through several stages of transformation before finally settling on the seabed and becoming juvenile sea cucumbers. A miraculous journey that helps maintain the balance of the marine ecosystem. Yet in hatcheries, this natural script is deliberately rewritten by humans. Carefully selected broodstock are kept in separate tanks, and with just a shift in temperature, salinity, or sometimes a small dose of hormone, sea cucumbers simultaneously release their eggs and sperm. Farmers immediately collect them in clean seawater and actively mix them to ensure artificial fertilization. Thanks to this method, the success rate can reach 80 to 90%, many times higher than in the wild. From tiny fertilized eggs, larvae are born, grow through multiple stages, and eventually settle on the seabed, marking the beginning of a new life cycle shaped by human hands. And every journey has a beginning. Let us ride the waves back to the mudflats and coral reefs along the Pacific, where specialized vessels are preparing to launch the season of harvesting sea ginseng, the precious sea cucumber. The harvest season usually falls between late spring and early autumn, when tides, water temperature, and currents converge into ideal conditions. Beneath the deep blue waters, beams from diving lights and acoustic navigation devices sweep across the seabed, searching for traces of sea cucumbers hidden within fine sand. In the past, harvesting relied heavily on divers. But on an industrial scale, a faster and more efficient method than manual diving became essential, and the answer lies in the use of specialized bottom trawl nets. Large vessels equipped with GPS navigation, sonar, and seabed mapping systems allow captains to pinpoint sandy areas and seaweed meadows where sea cucumbers tend to gather. Once the sonar indicates a high density, the crew lowers wide trawl nets, designed with mesh sizes suitable for catching sea cucumbers, while minimizing the capture of rocks, corals, or non-target species. As the nets drag along the seabed, a thin layer of sediment is lightly stirred, sweeping sea cucumbers into the collection chamber. The entire process is carefully monitored to avoid excessive damage to the environment. After the set trawling time, the nets are hauled back onto the deck, unloading hundreds of kilograms of fresh sea cucumbers into seawater washing troughs to remove sand and mud. Immediately after this initial cleaning, all sea cucumbers must be transferred into large ice-filled bins or circulated chilling systems. The speed and yield of this method make it the top choice for large-scale harvesting operations. Right after being harvested and pre-cooled at sea, sea cucumbers are packed into large plastic containers, sealed tightly, and neatly loaded onto refrigerated trucks. The internal temperature is kept stable at all times to prevent decomposition and preserve freshness. From the port, the trucks transport the sea cucumbers directly to the processing plant to begin production. As soon as the fresh batches of sea cucumbers arrive at the factory, they are immediately sent to the washing area to remove mud, sand, and mucus clinging to their bodies. Clean seawater flows continuously, rinsing away impurities and restoring their naturally smooth surface. After being washed a second time at the plant, the fresh sea cucumbers are transferred to stainless steel preparation tables, where workers wear full protective gear, gloves, and masks to ensure absolute hygiene. Before starting, workers must thoroughly wash and disinfect their hands using a specialized system, eliminating bacteria and contaminants so that the handling process takes place under the strictest sanitary conditions. The main tools are specialized knives or small stainless steel scissors, sharp enough for precision but not overly sharp, allowing easy handling. Workers carefully slit open the sea cucumber's belly, remove the intestines and internal waste while keeping the outer body intact. After the preliminary processing is completed, a portion of the fresh sea cucumbers is immediately transferred to the processing area to produce dried sea cucumbers, a product that can be stored for a long time and is convenient for transportation. Once thoroughly cleaned, the sea cucumbers are placed into boiling pots filled with seawater or a precisely measured saline solution. This process not only helps stabilize the texture of the flesh, but also preserves the distinctive, briny flavor of the ocean. Containing about 90% water, the flesh of sea cucumbers contracts under heat, releasing moisture and shrinking by approximately 30 to 50% of their original size. This shrinkage not only makes the sea cucumbers firmer, but also concentrates the sweetness and nutritional value within each strand of flesh. Due to this significant weight loss after processing, sea cucumbers are classified as a premium seafood. Every gram of the final product is precious, contributing to their high economic value and special status in the international market. Immediately afterward, they are neatly arranged on stainless steel drying trays, each spaced just enough to allow cold air to circulate evenly. The drying process takes place at an extremely low temperature, around 40 degrees Celsius, in a dehumidified and continuously ventilated environment. This temperature allows the remaining moisture to evaporate gradually, preventing cracks or surface deformation. Depending on the size and thickness of the flesh, the drying time can last from several hours to several days. The result is dried sea cucumbers with an intact shape, appealing color, rich flavor, and the ability to be stored for months or even years, while still retaining their nutritional value. Once the sea cucumbers have gone through the drying process and reach the required level of dryness, they are transferred to the packaging area, where every step takes place in a clean environment with strictly controlled temperature and humidity. First, each batch of dried sea cucumbers is weighed precisely to ensure the exact quantity as specified in the order. Workers then carefully place the products into plastic bags or vacuum-sealed pouches, removing as much air as possible to prevent moisture and extend shelf life. After vacuum sealing, the bags are tightly sealed and labeled with detailed product information, packing date, and expiration date. Next, the individual packages are placed into cartons or sturdy paper boxes, with added moisture-absorbing packets or bubble wrap for protection during transportation. The finished products are then stored in cold warehouses or refrigerated containers, ready to be exported worldwide or distributed to high-end restaurants and supermarkets. Sea cucumber is a premium seafood with a distinctive flavor. Tender yet firm, slightly crunchy, and naturally sweet with a refreshing oceanic taste, often prepared with minimal seasoning to preserve its pure essence. Rich in high-quality protein, low in fat, and packed with collagen, essential amino acids, and valuable minerals, it offers numerous health benefits. Since ancient times in China, Korea, and Japan, it has been regarded as a royal delicacy, a symbol of prosperity and longevity. Today, sea cucumber remains a prized ingredient in international cuisine, embodying both refinement and lasting luxury. In this video, few people know that New York was once the oyster capital of the world, where oysters blanketed the shoreline and were exported across continents. But after centuries of overharvesting, the industry completely collapsed. Now, with an annual investment of $6 million, the city is working to revive the oyster dream right where it all began. Once a luxury on dinner plates, oyster shells used to pile up as millions of tons of waste each year. But instead of letting them rot in landfills, people began returning the shells to the sea, where each one forms the foundation for reefs, filters water, and supports entire ecosystems. A remarkable shell turnaround, from waste to a symbol of ocean renewal. Oysters have no brain or central nervous system, but don't underestimate them. Squeeze a lemon on a raw oyster, and the citric acid instantly hits the soft tissue, causing it to twitch or clamp shut in a split second. It's a final biological reflex, a quiet movement that reminds us this seemingly lifeless creature is still alive. Before reaching dining tables or canning lines, oysters undergo a meticulous farming process that begins with the smallest details. To ensure a steady supply of seed and consistent quality, many farms now rely on artificial breeding instead of seasonal natural reproduction. Healthy broodstock oysters are carefully selected and raised in tanks with tightly controlled temperature and salinity, simulating year-round spawning conditions rather than being limited to the natural breeding season from June to August. Once fertilized, the eggs are incubated in 400 to 500-liter tanks containing millions of free-swimming larvae. This early stage is highly sensitive. The larvae are fed fresh microalgae, cultivated separately under strict quality control. Throughout this process, the tank water must be continuously filtered and regularly tested to eliminate harmful bacteria, ensuring healthy, uniform larval development, the foundation for high-quality oysters in the final product. When the larvae reach the stage where they are ready to attach to a fixed surface, they are transferred to specialized setting tanks. Here, crushed oyster shells are spread on mesh or hard surfaces to provide a suitable substrate for attachment. The juvenile oysters secrete a natural adhesive to anchor themselves in place, marking the beginning of a rapid growth phase. After about 2 to 3 weeks, once the spat reach a size of 0.75 millimeters to 2 millimeters, they are screened to remove weak or underdeveloped individuals, keeping only those with uniform size. At this stage, the young oysters are strong enough to withstand natural marine conditions and are ready to be transferred to outdoor grow-out areas. When oysters reach a size of around 4 to 5 millimeters, they are transferred to the ocean environment for further growth. At this stage, farms typically use 2 main cultivation methods: suspended bag culture and bottom culture. In the suspended bag method, oysters are placed in specialized mesh bags attached to metal racks or hanging lines on the water's surface. These bags come in various mesh sizes, ranging from 0.5 to 2 inches, designed to protect the oysters from predators while allowing continuous water flow to deliver natural food like phytoplankton. As the oysters grow, they are moved into bags with larger mesh sizes to ensure adequate space for development. In bottom culture, oysters are released directly onto sandy or muddy seabeds. This method results in thicker shells and a richer flavor due to direct contact with the ocean floor. However, it requires a longer grow-out period and regular monitoring to prevent loss and minimize the impact of natural environmental changes. After about 12 to 24 months, depending on environmental conditions and oyster species, oysters reach market size, typically between 5 to 7 centimeters, and are ready for harvest. By this stage, they have developed strong shells, plump meat, and their distinct flavor profile. Oyster farming goes beyond simply providing a suitable environment. It also involves essential care techniques, such as flipping the mesh bags, conducting regular inspections, and adjusting stocking density. All of these factors play a crucial role in determining the final quality of the oysters delivered to consumers. Each early morning, as the sea remains calm, fishing boats head out, cutting through the waves. Along floating farms near the coast, farmers work busily to harvest oysters, mollusks that grow silently, clinging tightly to submerged structures in the salty water. Unlike fish or shrimp, harvesting oysters requires patience and a solid understanding of their biology. Depending on the species and salinity levels, farms must wait 18 to 36 months before oysters are ready to harvest. Harvesting methods vary by farming model. In the floating rack and bag system, oysters are grown in mesh bags suspended from frames with 50 to 100 oysters per bag. When harvest time arrives, workers use pulleys to lift the bags onto the boat, a quick and efficient process that preserves freshness. In bottom culture or wild harvesting, oysters are collected using dredging nets that scrape along the seafloor. While this method yields a high volume, it can easily mix in mud and damage shells if not handled carefully. Oysters are highly sensitive to temperature shock and physical impact, so every step from harvest to processing must be strictly controlled in terms of time, temperature, and humidity. Once brought ashore, oysters still retain seawater inside their shells, as if carrying the ocean with them, preserving their freshness to the last drop. After harvesting, oysters must be cleaned immediately to remove mud, algae, and small organisms attached to their shells, ensuring quality before moving on to the next stage. The cleaning process involves multiple steps, combining automated systems with manual handling for optimal effectiveness. First, the oysters are passed through a series of recirculating water tanks with continuous or wave-like water flow, which gently loosens mud and debris without damaging the shells. In some systems, these tanks are equipped with filtration screens to remove impurities and keep the water clean throughout the washing process. Next, the oysters enter a specialized washing system, where high-pressure spray nozzles combined with rotating drums remove any remaining stubborn residue. Under the force of pressurized seawater or clean freshwater, the oysters are thoroughly cleaned from all angles, leaving the shell surfaces free of contaminants before proceeding to the next step. Once the washing process is complete, the oysters are transferred to an automated grading system. Here, vibrating conveyors sort the oysters accurately by shell size, ensuring product uniformity. In more advanced processing lines, optical sorting machines are also used. These systems employ sensors and imaging technology to inspect shell color, shape, and detect abnormalities, such as cracks or signs of poor quality. Oysters that do not meet the required standards are manually removed by workers, ensuring that only top-quality oysters move forward. After grading, the selected oysters are placed into specialized containers with drainage holes to prevent water accumulation and maintain optimal conditions for the oysters to stay alive and healthy. Thanks to a modern cleaning and grading process that combines technology with manual handling, the oysters are not only clean, but also consistently high in quality before moving on to storage and transportation. After grading, oysters are processed in two main ways: kept in shell or fully shucked, each method serving different processing purposes. For in-shell processing, workers gently pry open or slightly separate the top shell while keeping the meat and natural seawater inside intact. This method preserves freshness and flavor and is commonly used for live oyster distribution, especially to high-end restaurants where appearance and integrity are essential. After processing, the oysters are placed on ice trays to maintain freshness and keep them alive during transport. In contrast, full shell removal is used for further processed products such as fresh shucked meat, frozen oysters, or canned goods. Despite advances in technology, much of this process is still done by hand, as oyster shells are sharp, rough, and tricky to handle. Skilled workers can shuck up to 1,000 oysters per hour while keeping the meat perfectly intact. The oyster meat is then washed with high-pressure water to remove sand and shell fragments, and in some facilities, it is sanitized using ozone or diluted brine, extending shelf life without compromising texture or requiring chemical preservatives. Once the oysters have been thoroughly washed and sterilized, they are moved to a rapid cooling zone. In this area, workers spread ice over trays of oysters to instantly reduce the temperature, preserving freshness and preventing bacterial growth while awaiting packaging. This step is essential for stabilizing the meat quality before further processing or long-term storage. For canned products, workers carefully place batches of oysters into food-grade coated aluminum cans. Each can is precisely measured by quantity or weight, then transferred via conveyor to an automated sealing system. For canned products, workers place batches of oysters into food-grade coated aluminum cans. Each can is accurately portioned by quantity or weight, then filled with a light brine or a specially formulated sauce to enhance flavor and aid in preservation. Next, the cans are conveyed along a production line to an automatic sealing machine. At this stage, the cans are hermetically sealed using high mechanical pressure to prevent any air from entering. Immediately after, the oyster cans are sterilized in steam chambers at 115 to 121 degrees Celsius for a specific duration to eliminate bacteria and extend shelf life without the need for preservatives. Finally, the cans are rapidly cooled, labeled, and boxed, ready for domestic distribution or export. In addition to fresh and canned products, a portion of the oysters is transferred to a cold air drying line, where cool air is continuously circulated around the oysters to evaporate moisture without altering the structure of the meat. In addition to fresh and canned products, a portion of the oysters is transferred to a cold air drying line, where cool air continuously circulates around them to evaporate surface moisture without altering the meat's structure, preserving both flavor and nutritional value. Next, the oysters undergo a second cold drying stage at a lower temperature and for a longer duration. This process further reduces internal moisture, achieving an optimal dryness level for long-term storage without the need for additives. Once drying is complete, the oysters are cooled to stabilize their temperature, then tested for moisture levels. Workers weigh and portion each batch, place them into bags, and immediately vacuum seal them. This step helps prevent oxidation, limits moisture reabsorption, and extends shelf life. Finally, the products are boxed, labeled, and packed, ready for export or distribution to premium markets. Parsley is a biennial plant that's prized for its bright green, curly or flat leaves, and, in some cases, its nutrient-rich root. Parsley comes in two main varieties, curly leaf parsley and flat leaf parsley, also known as Italian parsley. The plant typically grows about 12 to 18 inches tall, with clusters of vibrant green leaves and delicate white or yellowish flowers in its second year. Parsley thrives in mild climates and prefers well-drained soil with plenty of organic matter. It grows best in temperatures between 50 degrees and 70 degrees F, making states like California and Florida ideal for large-scale production. Parsley requires plenty of sunlight, regular watering, and a steady supply of nutrients to achieve its lush appearance and rich flavor. Parsley is usually ready for harvest about 70 to 90 days after planting. In warmer regions, it can be harvested year-round, while in cooler areas, it's typically picked in late spring or early fall. Timing is crucial. Leaves must be harvested when they're at their freshest to ensure the best flavor and texture. With 121 million pounds of parsley harvested annually, it's clear that both efficiency and care are key in the harvesting process. Farmers use a mix of modern machinery and traditional hand-picking methods to ensure the herb's quality and freshness. In large parsley fields, industrial harvesting machines play a vital role in ensuring high productivity and consistent quality. These machines are equipped with sharp, adjustable blades that cut the parsley plants just above the ground. The blades are designed to minimize damage to the stems and leaves, ensuring the harvested parsley retains its vibrant appearance and freshness. As the parsley is cut, it's immediately lifted onto conveyor belts integrated into the machine. The conveyor belts are engineered to handle the delicate parsley leaves gently, preventing bruising or tearing. Along the way, the machines are equipped with systems to shake off excess dirt and debris, ensuring that the parsley reaches the storage containers in a relatively clean state. Modern harvesting machines can cover vast areas in a short amount of time, drastically reducing labor costs and increasing efficiency. They're often paired with transport vehicles that collect the parsley directly from the machines, allowing for continuous operation without interruptions. This seamless integration of machinery not only boosts productivity, but also ensures that the parsley maintains its freshness as it's swiftly moved from field to processing facilities. Machinery has revolutionized the parsley harvesting process, making it more efficient and less labor-intensive. For large-scale farms, machines can harvest thousands of pounds of parsley in a single day, significantly reducing the time and effort required compared to manual methods. This efficiency is particularly important in meeting the high demand for parsley in both domestic and international markets. Furthermore, harvesting machines are designed to be eco-friendly, with adjustable settings to minimize soil disruption and reduce waste. By optimizing the harvesting process, these machines help farmers achieve higher yields while maintaining the quality of the parsley. While machinery is efficient, many smaller farms or specialty growers still rely on hand harvesting. Workers move through the fields, carefully cutting each bunch of parsley with knives or scissors. Hand harvesting is particularly common for high-quality parsley used in gourmet cooking or fresh markets. The process of hand harvesting requires precision and care. Workers must ensure that only mature and healthy parsley leaves are picked, leaving behind younger shoots for future harvests. This method is labor-intensive, but allows for greater attention to detail, resulting in parsley of exceptional quality. On some farms, freshly picked parsley is placed directly onto portable conveyor belts that are set up in the field. This allows for immediate cleaning and packing, reducing the time between harvest and market. Portable systems ensure that the parsley retains its vibrant green color and crisp texture, making it highly appealing to consumers. Although hand harvesting takes more time and manpower, it's valued for its ability to preserve the parsley's natural appearance and minimize waste. This traditional method also provides employment opportunities in rural communities, highlighting the social and economic significance of parsley farming. Once the parsley arrives at a processing facility, the journey from field to kitchen continues. This stage is all about ensuring cleanliness, quality, and convenience for consumers. The first step in the factory is to clean the parsley thoroughly. The plants are washed multiple times to remove any remaining dirt, sand, or debris. High-powered water jets and gentle agitation are used to ensure that every leaf is spotless. After washing, the parsley is sorted by quality. Leaves with discoloration or damage are removed, leaving only the freshest greens. Advanced machines and trained workers work together to ensure that the parsley meets strict quality standards. Once sorted, the parsley is chopped into smaller pieces for easy use. Whether destined for fresh herb mixes, pre-chopped packets, or frozen products, the parsley is processed quickly to maintain its freshness. After chopping, it's vacuum sealed or packed in moisture-resistant bags to lock in flavor and extend shelf life. Some parsley is dried and packaged as a spice, ensuring that it can be stored for months without losing its aroma. While parsley leaves are the star of the show, parsley roots also have a role to play. Known as root parsley or Hamburg parsley, this variety is cultivated specifically for its large, edible root, which resembles a pale carrot or parsnip. The root of the parsley plant is starchy and mildly sweet, with a flavor that's somewhere between celery and carrots. It's typically harvested in the late fall, when the roots have reached their peak size and flavor. The harvesting process is similar to that of carrots, using specialized machinery to carefully dig up the roots without damaging them. Machines specifically designed for root crops, like carrot harvesters, are essential tools in collecting parsley roots efficiently. These advanced machines are equipped with rotating blades and digging arms that carefully lift the roots from the soil, minimizing damage during the process. Once the roots are unearthed, they are seamlessly transferred onto a built-in conveyor system. This conveyor moves the roots to sorting bins where excess dirt is removed, and the roots are thoroughly inspected to ensure they meet quality standards. The use of these machines significantly boosts productivity, enabling farmers to harvest large quantities of parsley roots in a fraction of the time it would take manually. This efficiency is crucial, especially during peak harvest seasons, as it helps reduce the risk of spoilage and ensures that the roots are promptly delivered to processing facilities. Quick transportation is vital for preserving the roots' freshness, flavor, and overall quality, making them ready for further processing or direct sale. By automating the harvesting process, these machines not only save labor costs, but also enhance the consistency and reliability of the harvest. Their precision and speed underscore their importance in modern agriculture, where demand for high-quality produce continues to grow. For parsley roots, this machinery represents a perfect blend of technology and practicality, supporting farmers in delivering fresh, flavorful products to markets with minimal delays. After harvesting, parsley roots undergo a similar cleaning process as the leaves. They are washed, peeled, and sometimes sliced or diced before being packaged. Parsley roots are often sold fresh or frozen for use in soups, stews, and other hearty dishes. Like the leaves, the roots are also dried and ground into powder for seasoning blends.